Hi folks, we're going to talk about the basics of electricity in this video, and so we're kind of answering this core question of what is electricity. So first we want to talk about electric charge here, and electric charge is a fundamental property of matter. So it's a fundamental property of matter. This means that, like mass or other things, it's something that things have, and there's no kind of reason for it. It's just electrons have this charge, protons have this charge. And there's two types of charge. There's positive and negative. And as we will talk about a bit in class, there's no real reason why we have to call positive positive and negative negative. We could easily swap them. We could call them charge A and charge B. We could call them blue and red. It's just a historical reason for kind of, as they were thinking about it, as they developed, they called one positive and the other being negative. But it is useful that they are positive and negative, as you'll see in a bit, for some math reasons. But what we ultimately care about is that there's two types of charge, and so if both of them are positive, then they will repel or push away. If they're both negative, they will also repel or push away. And if they're opposite, positive and negative, they will attract or pull towards each other. This is true for whatever amount of charge. If it's all positive, then those will push away from each other. If they're negative, they'll push away from each other. If we have a mix, then the positives and negatives will pull towards each other. So then, why are things charged? Well, protons and electrons have charge based on what kind of particle they are. So if it's a proton, it will be so protons are positive, electrons are negative. So everyday object charge is based on the balance of protons and electrons in that object. So if something like a big object, like say a glass rod, if that's positively charged, that means more protons than electrons. If it's negatively charged, that means there's more electrons than protons. And if it's neutral, that means that there's the same or nearly same number. The chances of there being literally the exact same number of protons and electrons is very low. So it's just if they're roughly the same amount, then it's neutral. If there's a lot more protons than electrons, it's positive. If there's a lot more electrons than protons, it's negative. So how do we actually measure charge? Well, charge is measured in coulombs, which we use a capital C for. And an electron has a charge of negative 1.602 times 10 to the negative 19th coulombs, and a proton has a charge of 1.602 times 10 to the negative 19th coulombs. So you'll notice it's the same, just opposite. Electrons are negative, protons are positive, and that's why all we care about is the relative number. So if there's more protons than electrons, then that's why it'll be positive. If they're about the same, then all the positives and negatives cancel out. This amount, this 1.6 times 10 to the negative 19th, is known as the fundamental unit of charge. And that's because it's the smallest amount of charge that we have that can exist. So charge can move from place to place, but the total amount must remain constant. And this is the law of conservation of charge. And this will make sense as we kind of think through it, hopefully. And this is because the protons and electrons have a fixed amount of charge. So you saw on that previous slide, a proton has 1.6 times negative 19th coulombs. Same thing with an electron, but negative. And we can't just randomly or arbitrarily create or destroy protons and electrons. So I guess created or destroyed. So those electrons and protons can move from place to place, and so that will change the amount of charge in the objects, but the total is constant. So if you rub, say, a balloon on your hair, well, maybe a bunch of electrons go from your hair into that balloon, but those electrons didn't disappear. So yes, your hair became positively charged and the balloon became negatively charged. But if you count up the total amount of charge that's there, it should still cancel out to 0. And that's the law of conservation of charge. So I'll wrap up here. If you have any questions, let me know. But otherwise, you can jump into the next task.